right, welcome back. My name is Corey. You're my rubber ducks, and today we're continuing our series. We're episode number, what was that? That's it, episode 28. And we are building a programming language from scratch using Vim, Bison Flex, well, modern-ish, modern where appropriate. How about that? C++. And yeah, it's coming along, this little language that we're building. Now, as it so happens, every once in a while, because we've been churning through feature, we've got all sorts of stuff, and we even have loops in the form of while statements. And quite frankly, whiles and do whiles are powerful enough that you don't need for loops, but we're going to add them, don't worry, but not today. Rather, what we're doing today is anytime that you are working on a product, sometimes you need to take a step back and evaluate your progress. See, where are you? Have I covered all my edge cases? Have I covered all my bases? Things like that. And a lot of times I do this programming late at night, and after I've already put in a full day work, and quite frankly, I just love coding. And some people like watching baseball. Some people like watching tennis. Some people like watching chess. Some people like to watch carpenters. Some people like to watch, you name it, on YouTube. There's a channel for just about everything. I like watching live coding, and that's why I'm putting out live coding stuff. I figure, well, maybe somebody else does, and they'll learn something from what I'm doing here. But also, if you follow along, you should pretty much have a really good idea about how it works to build, in this case, this particular programming language, and how to work with the tools that I'm using. And so that's why I've been doing this. Well, last night, when I finished my video, and I don't even remember if it was a long one or a short one, all that I know is that after I finished and I was editing the video, I saw something and I was like, wait a second, that may be a bug. And I've been thinking there's a few other things I've been wanting to refactor along the way as well, and we've just been kind of putting them off, or at least I have been. And we're going to hit those today, and hopefully not break anything in the process. That's why we have unit tests, to make sure things still work. And of course, I'm going to start here. If I say git log, you'll see the last commit was episode 27. And I always say there's nothing up my sleeves, right? I haven't done anything else to it. If we say git status, it will say on the master branch, nothing to commit, right? The tree is clean. I haven't done anything. Okay, so we are just in our main branch, and we're going to start, and I'm going to tell you what bug I think I found. And we're going to start by opening the test. Nope, that didn't finish. Test / it's already starting out spectacularly. All right, so, and over here we're going to say our make watch, or test - watch. There we go. Okay, at the bottom we did our do whiles, and the problem is, in this case, a is less than 10 is true, and in this case a is less than 10 is false, and I said, and it should be a null pointer, just like the while. The problem is a do while is not the same as a while. For the while, if the condition is false, the code block does not get executed. In a do while, it does get executed once. And if this code block is executed once, that is, this code block right there is executed once, well, B is not going to be oh, sorry, it's this one down here. But sorry, B is not going to be a null pointer, which is what I have there, and that's not good. B will still have the value of, so it says A is equal to A plus 1, and then, so A is equal to 1 starting out, A is equal to A plus 1 is going to be a 2, and so B should have a value of 2. Okay, what about this next one? This one is still A is equal to A plus 1, so A will equal to 2, B will equal to 2. That should be a 2. And of course, if I save it, it's going to tell me that it's failing this test. Why? Because I have a bug, and I had a bug in my test. I just made the same mistake in both places. Why didn't the computer catch that? Because I told it to do the wrong thing, and I told it the wrong answer to check against. Computers are dumb. They're just really fast. And I was a bit dumb when I wrote that. Let's fix it. As it turns out, the reason is really, really simple. I'm going to edit the Bison file. And let's just go down to where we... it's going to be somewhere in here. I'm having to scroll up. I could have searched for it, I suppose. But for the... do while, where is this? There we go. The while, wait, that's an open statement. Where's the close statements? It's up here. The do while. Okay. Do you see the problem? There. That, it should not be a while, it should be a do while. And because I did make the change, it was doing the expression and the statement in the right place. It was written as a while, so that's why it was behaving in the test the same way as the while did above it. And now, when I save this, all of our tests pass. That is what should be happening. Okay, so that is the first bug. And hey, it's solved. Let's, I'm going to get status, okay, get diff, just to make sure that, yep, that's the only things that are different. So I'm going to say get commit -am, and what is my commit message? Bug fix, Bison, not setting proper AST node type for do while. Sure. All right, first one down. I was thinking about another bug that might exist, and in fact, this is all live coding, so we need to test it. So I'm going to, we're going to do the test.cpp again, and at the bottom, I'm going to create another, no, it's on the while, so, well, it's probably going to exist on the do while as well, so I'll put it there. Sorry, just was lost in thought for just a moment. And this is number 5, this is number 5, and the question is, so I want to do this. A is equal to A plus 1 is less than 10. And I'm just, yeah. So see if this makes sense to you, first of all. Is this valid? Yes, because A is equal to A plus 1 is an expression. Say it's a statement. No, no, no. A statement is an expression that's followed by a semicolon. This is an expression, and it's a valid expression. So we are incrementing A, and then we're saying greater than 10. And that should be fine. We're going to compile it, and I'm expecting there may be an error. There is not. Okay, so let's do this. Let's cout p5 dot dump. That's it. Dump bytecode. And this, I will explain what I'm looking for. Again, the question is what is this going to result in, the open close? Oh, here it is. So we're going to start here at the top. We've got our A and B, integer 1, poke it into A, that's fine. Pop it off. Oh wait, no, pop the stack. Okay, now load A, integer 1, we're going to add, that's A is equal to 1. We're poking that into 0, and now integer 10 greater than, jump if false, while popping that result to 23. But what if it were true? Pop. Yeah. Here's the problem. I think it'll show up if I do this. While it's less than 10, there we go. Unaligned tcache chunk detected. What's happening? Well, it didn't print it out, so let's put it there. Put it in the wrong place. So okay, everything is correct so far. Integer 10, do the less than compare, right, and then jump if it's false while popping to 23. And then, so that removed the value from the stack. And now we're trying to pop, but pop what? You see, the problem is there is no statement in this code block. Yeah, there's nothing there. And yet, our while, what it's going to do is it is going to think that there should be something there, and then it's going to try to pop it immediately, and that's what this number 19 is. It's trying to pop whatever was put on here, but there isn't anything there. And so when it tries to pop and then jump to 7 and just redo everything, at some point it's going to try to get at B. Well, actually it's going to keep on trying to pop stuff off, but it's going to pop off memory location 1, B, it's going to pop off 0, and then it's going to try to pop off something that it doesn't have access to, and that's what's giving us the error. So what I think we need to do is for a code block, if it is empty, we still need to push an a null val. Now that can be optimized out, and in fact we'll write that down as an optimization, but we need to fix this first. So where is this going to be? This is in the compile, so it's going to be in the source for AST node block. And in the compile, there we go. If there is something there, then we just need to add an else. It must leave something on the stack. So leave a null. Yeah. We're going to say that by program add bytecode of a uint, no, yeah, of a uint 64T, which is an opcode, oh, null val, null val. There we go, complete with an error message that explains why it's there. See if it works. All of our tests pass. And now we see here, so jump if false to 24. That was the end of the condition test. Then push null val, pop it, jump to 7. So in our include Tang.hpp, where we're saying future optimizations, we're going to say this one. Push pop. Can be removed. What is the example? Just there we go. What's the example? 20 and 21. If, I'll say this, if 21 is not a jump target. Why? Because if 20 is a jump target and it gets optimized away, oh wait. I said it should be 19 and 20, not 20 and 21. So this should be 20, this should be 20, and this should be 19. Okay, so if 19 is the jump target and I remove both of them, then it will behave as expected. However, if 20 is the jump target, that means it was meant to meant to pop something. Sorry to yawn. All right. Let's go back to the test. That's good. And now, commit this. Yep, that's exactly what I expected. So git commit -am and there we go. All right, what's after this? Now, we've got oh, yes. I'm going to open the test again, but we're going to edit the AST node, the do while. The reason is we're just going to print out this P4. Okay. Now, if we look at it, it's a is equal to 1. That gets us down to the poke. And now, or the pop there, and we jump past the condition check because we compile the condition first, and we jump to here, we go through, now we jump back to the condition. The thing is we don't need to do all of this jumping around because it's actually written out in the order that it needs to be, right? We do the code block first and then do the condition check, and then if it's false, we jump back. So what does that mean for our code? We can actually optimize it. Right now, we stole the way of that the while was compiling, but we're going to do it slightly differently now. And what we're going to do is we're going to there we go. So to compile the code block and clean up the stack afterwards. So first of all, we're going to say I don't want to say this, but I do need to know where this is. So I'm going to say an auto of the code block start, can I say that, is equal to the size, right? And it's going to be where I'm about to compile. And then we pop off the last thing. And we know that this is safe now because we just fixed the other problem. All right, now after that, where is our condition? Right here, compile the condition. However, and this is interesting, we don't need to do it because what happens is we run the code block and then we just immediately run the condition, and then we say if the condition is false, jump to we need to, if it's jump if true, so we need a new opcode for this. That's okay, we can add a new opcode. So if condition is true, jump to the start of the code block. And I'm going to say jump up. And we're going to replace this with a true. That was not the right letter. Jump if true while popping. And where are we going to? Code block start. Now, you may think that's the end, except whatever called this compile is going to add an op pop. So add extra stack push, which will be removed by the calling code. I'll say parent AST compile. Sure. Okay, and that's going to be program.add bytecode uint 64t opcode. Let's just do null val. And everything else can go away. No more complicated. No more complicated stuff. It's as simple as when I get to a do while, execute the code block, do the condition, and if it's true, jump back up. And if it's not, well, push a null that's about to be popped. That can be optimized away in a later thing, in a later code change. But yeah. Okay. Now, if I 27, what did I miss? Oh, yeah. Should be a semicolon there, and it's going to complain about not knowing about the jump T pop. So we need to add that. Let's first of all edit the, normally I would edit the opcode first. I'm going to edit the program. Why? Because the moment I edit the opcode, it's going to compile and try to run it, and it's probably going to go into an infinite loop or something. So let's edit the source program. Yeah, we'll do the dump first. And where are we going to put it? So we've got it jump false. Do we want false first or true first? If we think of false as a 0 and a true as a 1, let's do that. So we'll do false first and then true. True. Okay. And now we're going to edit source program execute, and jump. We just saw it. There we go. Let's. Now this is going to be a true. And what all are we going to do? If condition equals true, then the program counter is equal to that. Else, just keep on going. Okay, now we need to add the opcode. And that's going to be in the includes opcode. Jump if true. If true, there we go. If it gives me a weird error, I know I need to do a make clean and then do this again. Looks like everything may be compiling. Okay. And I don't know which one this is. Oh no, it's the test. Of course. I did a dump bytecode of this. Why? Because now we can check it. What's it? What is it doing? That's A. That's B. Integer 1. Poke that into A. Pop the value. Peek the 0. So add or load A. Integer 1. Load that. Add them together. Poke that into A. So it's doing that. It's right there. And if we go down, we're doing a greater than check and jump if it's true with a pop to 7. And 7 is where we load A for the A plus 1. And if it's false, it just puts on a null val, pops it, and then loads the B value. Yeah, that is all correct. That's always good. Okay, so let's get status, get diff. Okay. I'm trying to say optimize. do while compile add jmpt pop opcode. Sure, that's pretty good. All right, now there's another thing that we wanted to do, and how are we on time? 30 minutes in. There's two other refactors that I want to do. I'll do one of them first. One of them is going to be, I don't like using the, well, here, let me, I don't think, no, I don't have it open, so I'm just going to have to WSL view, where is this? Docs, HTML index. There we go. And in my class, it doesn't matter, I'll choose any of them. I don't like compile identifiers. I already have a compile. Compile is not a good way. It needs to be either collect identifiers or gather. I think I'll go with collect identifiers. Or identify identifiers. You know, no, we'll say collect. That's probably better than gather. Yeah. So, how do we do this? Basically, there may be a fast way. Well, git grep, and I dash in, that adds the line number. Compile. You know what? That's probably not where I want to do this. CD. Well, git grep dash in compile identifiers. Okay. I guess there's not as many. There's in the node.hpp, because that's the default. Assign binary block do while identifier if else while. You know what? We'll do it this way. Start AST node star. And we're going to do a percent, nope, did that wrong, colon %s slash compile identifiers, and we're changing that to collect identifiers. Okay, and now we just need to do this over and over. That's fine if it didn't find it. Okay, so that was all of those, and now it's complaining about the AST node, so that's fine. In the includes AST node. Nope. I do this every time. The source AST nodes. There we go. Got them all. And this is as simple as rerunning that. Now, for this type of a change, it might be faster in modern IDEs, but also something tells me that I could have done this as a macro, and then it would be just be 1 or 2 characters, and I just don't know macros that well yet. Nope, didn't mean to do that. What do I need to do here? The unary wall. Oh. This should have one, and it doesn't. We need to add that. That's a bug! We'll do that in just a moment. The while, definitely need to okay, and now we're going to edit the where did I put that? Or where is that? Oh, it's in program. You know, that's fine. We'll fix that in a moment. For the include AST node unary. And the source AST node unary. And you know what? Edit the include for AST node binary. Sure, why not? Why? Just because I need to grab this line. There, it's gone. And now I need it here. And if I edit the source for AST node binary, I can steal its. And it needs to be on the operand. Okay, and now it's still saying in the, oh, because that should be unary. There we go. And in the program.cpp, so the edit for the source program.cpp on line 40, it should not be compile identifiers. It should be, what is it? Collect identifiers. All tests are passing. Okay, so we've effectively refactored it. So again, could modern IDE do that faster? Probably. That took me, what, about 10 minutes of juggling files. There's probably a faster way. I just don't know. There's probably a faster way of doing it in Vim. I just don't know what it is off the top of my head. All right, now the last thing. Oh wait, let's commit. You say, Corey, why do you commit so often? Because, first of all, when you solve one problem, just, check it off your list. The problem is if you don't, then you will forget, or you'll try to solve another problem, get yourself in, or worse yet, 2 or 3 problems in a row, and you'll get to a point that it's broken and you can't find what your changes were because all the old changes are in there. So once you solve a problem, commit, definitely. And that should be -am. And what did we do? We rename AST node compile identifiers to collect identifiers. Sure. Okay. And we added a missing one, but that's fine. Okay. All that clear, we've got one more refactor that I want to do. And I've thought about this long and hard. I've done it once in one of the languages that I wrote. Like I said, I wrote a programming language twice in preparation for this, trying out different things. I did this once, I didn't do it another time, and I don't remember the order, it doesn't matter. And that is, we have an AST null type. And at the same time, we have an AST node that we're not using other than the base class. And what I think I want to do is I want to, instead of having AST node null, I want AST node to represent a null type. And I want a regular computed expression to be a computed expression null. So in other words, the computed expressions were set up the same way. We have a computed expression type, and then we've got a computed expression null, and the computed expression itself is never meant to be used. And I don't think that that's a good choice. The more I've thought about it, and this has been in the back of my mind for several weeks. Not several weeks, sorry. I've only been writing this for a while. Anyway, for a couple weeks. But anyway, so we're going to make that change. How do we do that? Well, couple steps. First, we're going to edit the make file. And I'm going to search for the nulls. There's one. So search for the next one. There we go. Search for the next one. That's going to be a D4. Search for the next one. D4. Okay, it is erased from the nulls, isn't it? Yeah, pattern is not found anymore. All right, now the hard part. Move all, well, it's not really hard, it's just we're going to move all of the functionality. So Vim source AST node, no, not source, I want to do the includes first. Include AST node, source AST node, include AST node null, source AST node null, and then include computed expression, source computed expression, include computed expression null, source computed expression null. Okay, there's others, but for right now, that's what we'll do. So right now, the constructor is protected, and we're going to yank that out there and put it public. Yes. That's the first change. Change number 2. So we need to compare no class null. What does it say? I should probably say the base class a null value. Okay, that's fine. So B3, the constructor, basically we have a constructor, we've got a dump and a compile. That's what we need to do, the dump and the compile. So the dump, what does it have in it? Oh wait, this is astnode.hpp. This is the astnode dump. Let's see what the one is for. There we go. And now the compile is no longer going to be actually something's about to change in these, but we'll get there in just a moment. Actually, we're about to be there. The problem is these are virtual. They're able to be overridden, and what if whoever overrides it forgets to implement it? In that case, we need to make sure that we only take these actions if we are in fact an AST node and not an AST node of some type that somebody overrode and forgot to override this virtual function. How do we do that? Well, we do something like this. We will say return, and it is the type ID of this is equal to the type ID of AST node. That's the question. If so, indent plus null. Otherwise, indent plus unknown. And we don't need that. Now I'm going to copy this and put it down here and say if that okay, so we should have the same behavior. Opcode has not been declared, so I need to include opcode.hpp. All right. So I think that's all we need to do for AST node. I am going to say this is is actually not a, can I say child type, derived type? Does derived have one R or two? We're going to look it up. Nope, just one. I had it right the first time. It doesn't look right with two R's, but okay. And not a derived type that forgot to override the virtual method. All right, we've got that there, and we're going to put it here as well. Okay, so that will take care of the AST node ones. 1, 2, and 4 now. V1. For AST node null, yeah, I can get rid of that, which we will in a moment. We have to use get rm. And now we are at the computed expression. Same thing. A null value. All right. Oh, so many things, but that's okay. But for next, we've got the dump, the make copy, the is equal, and the garbage collected. What do I even need this? I don't think so. So let's just do them in order. For the dump, return null. We're going to have the same issue as before. So the dump here is going to be return type ID of star this is equal to the type ID computed expression. If so, null, otherwise unknown. All right, and I think I want to go back to the source for the AST node. Y2. Nope, back. Okay, that's there. For the make copy, that's fine. For the is equal of a null pointer t, again, we need to protect. We need to make sure that we're only doing this for is equal null pointer t. So if, yeah, it's defaulting to false. However, if this is truly just a computed expression and I'm saying is it a null, true. That is fine. And now, hey, we're on to the last one. Computed expression null equal computed expression null dunder equal. Okay, so first we're going to say this. And now we need to, what is this, line 84? That's fine. I need to go up. There's probably a faster way, but I don't know what it is off the top of my head. Where did I say we were? 84. And I need this here. If then all right, so if the type ID, if I'm actually a computed expression and the right hand side is also a computed expression, then do true, else okay, wait. There we go. And I didn't want to get rid of that. Okay, so if I am a computed expression and I'm comparing against a computed expression null, not null, just a computed expression, there we go, return true, otherwise false. Why false? Because I am actually computed expression. There we go. Otherwise, do a default. Don't know how to compare. Okay. That's all of them. All right, so garbage collected, blah, blah, blah. Oh, it doesn't know what a garbage collected Boolean is. Gotta add that. Computed expression Boolean, not garbage collected. Everything should compile so far, but we're about to do something that will make it not. Undefined references, because they're no longer in the compile of these, AST node and computed node null. That's fine. We're about to really figure out where they are. So how are we going to do that? Get rm, the include AST node null, the source AST node null, the include for computed expression null, and the source for computed expression null. And now it should really start complaining because it should be saying, hey, I can't find these things. Nope, it didn't. Let's make it. Make clean. There we go. Okay, what is this in? Computed expression Boolean. Okay, so that is in source computed expression Boolean. We're going to look for the null. It's the only place. Where else? Oh, the float. That's fine. Source, whoops. Edit source computed expression float. Looking for the nulls. There we go. Integer computed expression integer. Again, the nulls. Search for it. Search for it. Is it doing it again? We're compiling. This is in. Why is it? Oh, program execute. That makes sense. Program execute. It doesn't have computed expression null. That's it. And this is in, oh, Bison, yep. I knew that would be one of these. Okay, that should be all of them. That seems to be it. So we've deleted 4 files, got rid of 2 classes, and got these changes. Let's go back to that AST node null in just a moment. Right now doing our spot check to make sure everything looks right, and it does. So I wanted to see, what was it, the include for AST node.hpp. And first of all, this right here, this protected, does it still need to be protected, or can it be private? Private's fine. Okay, so if that's the case, I'm removing it. And there we go. Putting it at the bottom, which I normally do. And again, everything should be fine. And in fact, what I would normally do at this point, in fact, I'm just going to make clean, make test. While that is doing that, oh yeah, I mean, I just did this, but okay, if the tests finish, we'll be in good shape. The tests are all good. Let's commit it. So git commit -am, and what is our commit message? Remove AST node null class remove AST node and computed expression null, make base classes null by default. There we go. Okay. 150 deletions. Good. We may be at a net negative for today. I can only hope. So now we need to remove the docs, make docs-pdf, make it regenerate everything. It's going to be missing some files now because they no longer exist. And if we verify this, just make sure, yeah, we no longer have the nulls, but in our AST node, I think we have a constructor listed now because it wasn't public before. Yeah, no, that is very good. I'm happy about that. For episode, what is it? We looked at it at the beginning of episode 28. Again, I am amazed that we are so far in episode 28. Get status first, just to make sure. We're good. Get tag 028. The message is also episode.028. Zero to 8. As always, we are, yeah, I think we went down in lines. Zero to 7. Yeah. Last time we were at 3362, and this is pure lines of code, not counting comments. 3362, and now we're down to 3329, and we have bug fixes and a little simpler layout, and we even added a missing gather, whatever it's called, gather identifiers. And there we are, back to where we should be. And with that, oh my, we did a lot. But with that, I think we are ready to call it the end of an episode, and we went a little longer than I was anticipating, but we got a lot of refactoring done and got some bugs fixed, and hey, that's always a good thing. Next episode, I think we're going to tackle the for loop and the idea of an perhaps an empty statement. What does that mean? A statement that's just a semicolon, which is something you would expect to see in C++ or JavaScript, but not in Python or something like that. But we will need those, and for our for statements, our for loop, it'll have the three parts: initialization, the test, and the increment. We'll do that. So, as always, hope you have a great day, and we'll see you next time. Bye.